Okay, chapter 6.2, solving systems of linear equations. Okay, this time we will solve the system of linear equations by using the substitution method. In the last section, we used the graphing method, but graphing method is not accurate, so it is hard to find the solution, unless you graph it exactly, accurately. But this time, we will use substitution method. Okay, so when you solve a system of linear equations, there are three methods. One is graphing, which is, we don't recommend. And the second method is substitution method. And the third one is elimination method or addition method. The third one and the substitution method and the elimination method is very useful. So when we use the substitution methods, okay, we will change one equation in terms of x or in terms of y. So we would write it something like this. Y is equal to 2x plus 1. So rewrite the equation so that we can write the equation in terms of x, or x equals something like this, like 3y minus 1, something like this. So we can write the equation in terms of y. Okay, so one left side of the equation is x or y. So and all other terms will be on the right hand side. So this is what we're gonna rewrite. Okay, rewrite it like this. So here is an example one. I want to solve the system, this system of linear equations. So this is, let's say, equation one. This is equation two. Okay, equation one and equation two. And then we will rewrite this one so that the left side of the equation is x is equal to something y something, or y is equal to something. So it is better to rewrite the equation number two, because equation number two has negative x. So what we do is we can have x on one side and others on the right hand side. But using equation one, if we use equation one, once we rewrite it as x equals something, then we have to divide it by 3, the coefficient 3. So we may have the fractions instead of integers. So when you use a substitution method, make sure all the terms are in integers. The coefficients should be integers. It's much better. So okay, we will rewrite equation 2. Okay, we will rewrite equation 2 in terms of y. So x equals something. Rewrite it as x equals something. All right? So from equation 2, negative x plus 2y is equal to 4. So rewrite this as x equals something, because we have the coefficient of x is negative 1, the coefficient of y is 2, so we don't want to divide by 2, because if we divide by 2, then we may have 1 over 2x. So we have a fraction, so we don't like fractions. So leave negative x and then move 2x to the other side. Okay, so minus 2x each side, minus 2y each side, so that we can rewrite it. So negative x is equal to negative 2y plus 4, and then divide each side by by negative. Divide each side by negative or multiply by negative, then we have x is equal to 2y minus 4. Make sense? Multiply each side by negative. Multiply each side by negative. Okay, if you're not sure, then let me write it here. So I'm going to multiply each side by negative. Okay, each side by negative, so that the left side is x, the right side is 2y minus 4. Right? So x is, the expression for the x is 2x minus 4, right? So I'm going to replace. So we got this expression from equation number 2. So our substitute this. Okay, substitute 2y minus 4 for the variable x in what? Equation 1. Okay, so we got x from equation 2, then use equation 1 to replace x. So this will go where? So this So this will be going to this x, right? X. So from the equation 1, so equation 1 is 3x plus 4y is equal to -2. So we're gonna substitute dx, the variable x, with what? The expression of x we got from equation 2. Okay, this is simple, very simple. You have, expression for x from equation 2, and then rewrite x in equation 1 with the expression. Okay, and then from here we can solve for solve for y. So distribute, so 6y minus 12 is equal to -2, and then plus 12 each side, so that we can find 6y. 6y is 10, then y is 5/3. Wait a minute, we shouldn't have we should have this number. Let me double check if I write the questions correctly. Okay, I found the error. This is negative. Okay, I forgot writing 4y, right? 4y. Sorry about this one. I forgot writing 4y. Okay, so 3x. X is 2y minus 4. So x is replaced by 2x minus 4 that we got from equation 2. And then plus 4y is equal to -2, right? Okay, I forgot this 4y. And then this is 6y minus 12 plus 4y is equal to -2. Okay, we have like terms, two like terms. So combine these like terms. 6 plus 4 is 10y minus 12 is equal to -2. And then we want to solve for y. This equation has only the variable y, right? Variable y. So leave 10y on one side and move -12 to the other side. So -14. 10y. This is plus 10, right? So this is positive 10. Okay, then divide each side by 10, so y is equal to 1. So we found the value of y. So y is equal to 1. The solution means, what do you mean by the solution? Solution is the intersection of two lines. And we know y. Okay, we know the coordinate of y, so y is 1. So we can use either equation 1, 2, or anything, any equation that we transformed. So why don't we try using this expression? Let's say this is equation number 3. Because we already rewrite the equation as x equals something, right? So from equation 3, this equation 3 came from equation 2, right? Equation 2. So from equation 3, we have x equals 2y minus 4, right? And then we will replace this y with 1. Okay. From 3, we will replace y from this equation 3. So 2 times y is 1, right? So x is equal to 2 minus 4, x equals -2. So we found the coordinates of x and y. So when x is -2 and y is 1, this point is the intersection. This is the solution. Therefore, the solution is -2 and 1. Okay, so substitution method is really simple. Rewrite one of these two equations as x equals something, y equals something. And then use this expression to replace x or y in the other equation. Okay, in the other equation. Okay, so let's try problem number 1. Okay, problem 1. Solve the system of equations by substitution. So 7x minus y is equal to 4. The second equation is 3x plus 2y is equal to 9. All right. So we have, okay, let's say the first equation is equation 1 and equation 2. So which equation should we change? Much easier. Right, equation 1 is better, right? From equation 1, we can rewrite it as y equals something. So 7x minus y is equal to 4. So minus 7x each side. Then negative y is equal to negative 7x plus 4. And then multiply negative each side. So y is equal to, multiply negative, so negative positive. So negative 7x becomes positive x, plus 4 is negative 4. And then what's the next step? Okay, we have this expression. Okay, this expression is y. So we got this expression from equation 1. So that replaced y from the second equation with this expression. Make sense? Okay. So we got y from equation 1. And then from equation 2, replace this y with the equation, with the expression. So from equation 2, which is 3x plus 2y is equal to 9, I will use, so let's plug it in here, right? Yeah. So 3x plus 2 times y. Y is 7x minus 4 is equal to 9. 3x plus 14x minus 8 is equal to 9. And then combine the like terms. So 17x minus 8 is equal to 9 plus 8 each side. So 17x is equal to 17. So from here, x is equal to 1. So we found the value of x. So let's find y. Okay, y. Okay, so let's say this is equation 3. Let's say this is equation number 3. So from equation number 3, we can find y directly. So y is equal to 7x minus 4. So y is equal to 7 times, what is x? 1. So y is equal to 7 minus 4. So y is equal to 3. So we find the solution of this system of equations. So the solution is what? X equals 1, y is 3. Always write down x coordinate first, x. Does it make sense? Okay, so we will select either equation 1 or 2 to rewrite the equation as x equals something or y equals something. Okay, and then use the other equation to find a variable of x or y. All right, but what happens? When we solve the equations, what happens? In this case, we have an exact value x equals something or y equals something. What if when you solve a system of equations, right? Let's say equation 1, equation 2. When you solve this one, and then sometimes we may have something like this. 3 equals, we're supposed to have x equals something, x equals 2, or something like this, right? But what happens if we have the variable x is gone? Sometimes we may have 3 equals 5. This is false, right? False equation. Or sometimes we may have 3 equals 3, which is true equation, right? True equation. The equation is sorry, not this one. For example, 3 equals 3. True equations, or 0 equals 0, or etc. Then the conclusion is different. If x equals something or y equals something, right? Y equals something, then this means there is a solution. There is a solution. Okay, this is very important. So once we have x value or y value, then there is a solution. Okay, but if the result is a false statement like this, false equation, if the equation is true, then we can conclude that the solution has no solution. The system has no solution. This is really important. Okay, so when you solve the equation like this, so in this case we have x equals 1, so that we can find y value, then there is the exact solution. But if we have, instead of x equals 1 or y equals 1, we have something like this number, 3 equals 5 or 1 equals 2, which is the equation is different. Then we conclude that the system has no solution. Okay, the third type is if the result is true. If the result is true like this, 3 equals 3, 0 equals 3, 0 equals 0, 5 equals 5, true equation. If the equation is true, then there are infinitely many solutions. Many solutions. So the system has infinitely many solutions if the result of the equation is true. So do you remember when you solve an equation? When you solve an equation, system of equations, there are 3 types of solutions. 1, exact solution. There's a solution, exact solution, and there's no solution, or there are infinitely many solutions. So when we use a substitution method or elimination method, we will have these 3 types of equations. 3 types. One gives us exact value of x and y. Another one, the equation is false, then we conclude it, there's no solution. And if the equation is true, then what? The system of equations has infinitely many solutions because 2 equations are identical. Alright, so using this information, let's try different examples. Okay, example 2. Let's solve this system of linear equations by substitution. Okay, so let's say the first one is the equation 1, the second part is the equation 2. And already equation 2 is written in terms of x. So why don't we just directly plug in this expression for y in the other equation? Okay, so we got y from the second equation. So we will replace y from the first equation with the expression. Alright, so from the equation 1, we already, the equation 2 is already written in, y equals something. So use this information to rewrite y in equation 1. So 4x plus 2, y is equal to 5. So replace this y with negative 2x plus 1. Okay, then 4x minus 4x plus 2 is equal to 5. Then, okay, 4 cancel out. 4 and negative 4. When you combine these two, cancel out. So we have 2 equals 5. Look at this. This is a false statement, right? False equation. The equation is false. So what's our conclusion? False means no solution. The 2 lines are parallel. So equation 1 and equation 2 are parallel. Okay, false equation, then our conclusion is what? No solution. This is really important, no solution. So the system of 2 linear equations has no solution. Make sense? Okay, no solution means 2 lines are parallel. Okay, let me rewrite. Let me additionally explain this one. Okay, if the equation is false, then line 1 and line 2 are parallel. This means 2 lines are parallel. Okay, and then if the equation is true, then line 1 is exactly same as line 2, identical. Okay, and if we have x and y values, then there's a solution, which means there is an intersection, only exact solution. Okay, so this means, so since we have an equation that is false, 2 lines are what? Parallel, so there's no solution. Okay, let's try problem number 2. So problem 2. Okay, solve the system of linear equations. 3x minus y is equal to 4. The other one is y is equal to 3x plus 2. Alright, so let's say the first one is the equation 1, the second equation is number 2. So same as the example, the second equation is already written in y equals something. So why don't we replace y from the first equation with this expression? Okay, don't plug in this one in the second equation. So once we got y from equation 2, then you have to rewrite this y from equation 1, the other equation. Alright, so from the equation 1, 3x minus y is equal to 4. Then I want to replace this y with this expression. So minus stays, right? Minus stays. and the y is 3x plus 2. Don't write it like this. You have to put parentheses. Because this minus is the opposite of y, or opposite of y. So y contains two terms. So you have to protect this term, this expression within the parentheses. Always put parentheses when you substitute, put parentheses. Okay, so that is equal to 3x minus 3x minus 2. Multiply each term inside the parentheses by negative. Then combine these two becomes 0, right? So negative 2 is equal to 4. All right, so same as this one. This is false, right? False equation. So what's our conclusion? Therefore, there is no solution, right? Good, no solution. So the system has no solution, which means two lines are parallel. Two lines are parallel. So line 1, no, line 2 are parallel, right? Even this one, line 1 is parallel to line 2. Okay, let's try a different example. Okay, example 3. Okay, let's say the first equation is equation 1, the second equation is equation 2. Okay, already the second equation is written in terms of y, in terms of x. So just like the previous example, rewrite y in the first equation with the expression in equation 2. So the equation 1 becomes, okay, equation 1 is 6x minus 2y is equal to 4. And then 6x minus 2 times, okay, y is 3x plus 2. 3x minus 2 is equal to 4. So 6x minus 6x plus 4 is equal to 4. And then combine these two become 0. So we have 4 equals 4. Look, we're supposed to have x equals something, y equals something to have a solution. But in this case, the equation does not contain x or y. Just 4 equals 4. So this is true equation. True equation. Then what's our conclusion? Right. If this is true, then that means two lines are identical. They're same, not same. So that means two lines are identical, equal. This means line 1 is equal to line 2. So our conclusion is true equation. There are infinitely many solutions. Okay, infinitely. We use infinite symbol. All right, let's try problem number 3. Okay, why don't you try this one? Pause and try. Okay, so if we are done, okay, let's say this is equation 1, the second line is equation 2, and then in this case, the first equation is already written in terms of x. So x equals y equals something, right? Y equals something. So this time we will replace y from the second equation using the expression in equation 1. Make sense? So we got y from the first equation and then replaced y from the second equation. Okay, then from the second equation, which is 6x plus 3y is equal to 3, then replace this y. So y will become negative 2x plus 1. So 6x minus 6x plus 3 is equal to 3. Combine the like terms. Then we have 3 equals 3. This is true, right? True equation. So what's our conclusion? Now, true equation is not a conclusion. True equation means just an equation is true. Conclusion is what? Do we have a solution? Does the system have solutions? No solutions or infinitely many solutions? That's the answer. Okay, we should answer in one of these three. So our answer is yes, there's a solution, but the solution is what? There are infinitely many solutions. There are infinitely many solutions. So give one value of x, then you will get y value. Give another x value, then you get the y value. So there are infinitely many solutions. All right, so please make sure that there are three types of solutions, right? There are three types of solutions. solutions of system of equations. System of equations. Okay, the first one is what? Once you x plus something. Okay, you have an equation 1, equation 2, right? So if the equation 1 and 2, once you graph equation 1 and equation 2 like this, so equation 1, equation 2, right? So there's the exact solution. There's the exact solution, right? There's an exact solution, so we have some value x or y. Okay, another example is two lines are what? Two lines are parallel, right? Equation 1, equation 2 are parallel. That means the system will give you some kind of x equals 5, or 3 equals 5, or 4 equals 6. False. It will give you the false equation. Then we will conclude it as no solution. Okay, no solution. Okay, the third type is what? The third type is two lines are equal, right? Line 1 is equal to line 2. Then what's our solution? There are infinitely many solutions. There are infinitely many solutions, right? And then our conclusion will be something like this. 3 equals 3, 4 equals 4, 0 equals 0, and so on. So once we have a true equation like this, true equation, then our conclusion is there are infinitely many solutions. All right, the system of the system, we call the system, if there's exact solution, if there's a solution, then we call the system is what? Consistent. Remember, consistent. And this one is a solution, so this is consistent. And parallel, there's no solution, so the system is inconsistent. Remember? And then if two lines are equal, exactly the same, then we call the system is dependent. So this is dependent system, and the others are independent, right? Independent and independent. Make sense? So this is just a summary. So when we solve a system of equations, we can use substitution, right? Substitution. So substitution, you rewrite one of two equations in x equals something or y equals something, and then replace that variable from the other equation. Okay, please practice. Okay, practice. We are done for this section.